Students, now we are going to learn about ionization enthalpy. Enthalpy means heat. What is meant by ionization enthalpy or ionization potential or ionization energy? What is that? It is said that ionization energy means energy required to remove an electron from an outermost shell of an atom. So, how much energy required to remove an electron? When an electron is removed, the atom it becomes into a cation by the loss of an electron. It is measured in kilojoule per mole. Ionization enthalpy measured in kilojoule per mole. So, in the periodic table, in the p block element, this is a period from left to right, and this is the group. So, group, this is the period, this is the group. If you are taking the first period, boron, carbon, nitrogen, oxygen, fluorine, neon. Boron, carbon, nitrogen, oxygen, fluorine, first period. What happens on moving from left to right? Atomic size get decreased. For example, starting, then goes on decreasing. The size get decreased. What is the reason for this? Why the size get decreased from left to right? Because all the electrons added to the same electronic level or same shell. Due to that, atomic size get decreased from left to right. So, but even though the nuclear charge increases by 1, for example, boron 5, carbon 6, nitrogen 7, then 8, then 9. Even though the nuclear charge increases by 1 unit, the atomic size get decreased because all the electrons added to the same electronic level. So, in this case, ionization energy get increased. So, we require a large amount of ionization energy to remove an electron from the outermost shell. Why? Because if the size is very small between the nucleus and the outermost shell, the distance becomes less. So, attraction is more. When attraction is more, contraction happens. Contraction, the outermost shell gets shrink. When it shrinks, the atomic size gets decreased. This is the reason for this one. Now, if you are taking a group, for example, boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, then thallium. What happens? The size get increased. Why? Why? Because on moving down the group, new shells become increases. When the new shells occupies, when the shell number get increased, the attraction between the nucleus and the outermost shell, the distance become more. Since the distance become more, the attraction between the nucleus and the outermost shell becomes less. So, the electrons are loosely packed. So, electron can be easily removed. We don't want to apply more amount of energy. Only lesser energy is required to remove an electron. So, on moving down the group, since the attraction becomes less, ionization energy get decreased. When the atom size is bigger, the distance between the electrons and the outermost shell, the distance get increased. So, the electron present outside the shell can be pulled easily. But in the case of a smaller sized atom, the distance between the nucleus and the outermost becomes less. So it is difficult to remove the electron. So we require more amount of ionization energy. So now, if you are taking the p block element, 18th group, neon, argon, krypton, xenon, radon, 18th group, all the shell get fully filled. So it is impossible to remove an electron or add an addition of an electron. For an addition of an electron, there is no place because it is fully filled. For removal of an electron also it is difficult because the shell is fully filled. Octet structure difficult to remove because it is a stable electronic configuration for the noble gases. Hence it is stable. Regarding all the other groups, the ionization energy get decreased. See the halogens, energy is 1681 for fluorine, then 1251, then 1139, 1008 goes on. This is the radioactive isotope, so no ionization energy. Likewise, 16th group also, the ionization energy goes on decreases. Similarly, nitrogen group also, see, the ionization energy goes on decreases. Here also, 14th group, it goes on decreases. All are correct. But see the boron group, 800 for boron, then aluminium 577, then gallium 578, increases by one number, but it should be less when compared to this one. But this number increases by one number, then still it get decreased, then once more it get increases. What is the reason for this one? Why aluminium 577, gallium 578? What is the reason? Now we consider the electronic configuration. Boron, then aluminium, gallium, indium, thallium. Boron atomic number 5, aluminium 13, gallium 31, indium 49, thallium 81. Configuration, helium configuration, 2s2 2p1. Aluminium configuration, neon configuration, 3s2 3p1. Gallium, argon configuration, 3d10 4s2 4p1. Indium, krypton configuration, 4d10 5s2 5p1. Thallium, xenon configuration, 4f14 5d10 6s2 6p1. For boron, 2s2 2p1, it is easy to remove the p electron. Gallium 3s2 3p1, okay. See aluminium, see gallium 4s2 4p1, before that 3d10 is there. So when aluminium, for aluminium, nucleus, first shell, K shell, then L shell, M shell, only one electron present outside, distance is somewhat less, so this electron can be easily removed. Now, if you are taking gallium, nucleus, first shell K shell, then L, M, N, third shell 3D having 10 electrons, then 4p1, 1 electron. Here, if in the nucleus positive charge due to proton, so attracts the outermost shell electron towards inside. So if the electron comes inside, the inner shell electrons, here 10 electron present in D subshell, Then inner cell electrons. Electron, same charge. When this electron also pulled inside, they get repelled. So it can't able to move inside. Similarly, one more reason, 3D subshell is somewhat diffused deep inside. So since it is deep inside, the last electron cannot move further inside. So due to poor shielding, shortly if you are telling, it has poor shielding effect. Due to poor shielding effect, this electron cannot move inside. This is the reason for that is aluminium and gallium. Gallium having more ionization energy when compared to aluminium, due to poor shielding effect of 3D electrons. So this is the case for ionization enthalpy. This question will be asked. Why gallium having more ionization energy when compared to aluminium? If it is asked, this is the answer for this one. Due to the poor shielding effect of 3D electrons, since it is in diffused state. That is the reason for gallium having more ionization energy than aluminium. It is clearly given in your book. Children, you can go through, read, and if you can't understand, watch the video repeatedly. Surely you will understand, and you can mark it in the book.